In 1975, a Soviet research vessel pulled up a tooth from the floor of the Pacific Ocean. The tooth was 18 centimeters long, triangular, and serrated like a steak knife. When scientists dated it using the manganese dioxide crust on its surface, the result came back at roughly 11,000 years old. That date was a problem, because the animal that grew that tooth was supposed to have been dead for 3.5 million years. So the question we're going to answer today isn't whether Megalodon could exist down there. It's why, after a century of looking, we still can't say for certain that it doesn't. To understand the question, you have to understand the animal. Otodus megalodon was the largest predatory shark that has ever lived. Adult specimens reach lengths of around 15 to 18 meters. That's the length of a city bus. Some estimates push them to nearly 20 meters. Their bite force was calculated at over 100,000 newtons, roughly 3 times stronger than a Tyrannosaurus rex. They cracked the skulls of small whales the way a person cracks a walnut. We know all of this because we have the teeth. Thousands of them. Megalodons shed teeth the way a modern shark does, constantly, for tens of millions of years. Every continent except Antarctica has yielded them. So if we know so much about this animal, here's the obvious question. What killed it? The mainstream answer is climate. Around 2.5 million years ago, the planet entered a series of ice ages. Sea levels dropped. Coastal nurseries where Megalodon raised its young disappeared. The whales it hunted began migrating to colder waters where Megalodon's body, optimized for warmer seas, couldn't follow. That's the story. Cooling oceans, vanishing food, a giant that couldn't adapt. But there's a problem with this story. The problem is the fossil record itself. When paleontologists say Megalodon went extinct 3.5 million years ago, what they actually mean is this. The youngest tooth they have found, the one most reliably dated, comes from around that period. That's not the same as proof of extinction. It's the absence of evidence. And in marine biology, the absence of evidence is everywhere. According to the National Oceanic and Atmospheric Administration, around 80% of the world's oceans have never been directly observed by humans. We have better maps of the surface of Mars than we do of our own deep sea floor. And here's the part that most people don't realize. The deep ocean does not preserve fossils the way shallow seas do. Teeth that fall in the abyssal trenches sink into thick layers of soft sediment. They're crushed by pressure, dissolved by chemistry, and scattered by currents. We don't excavate the deep ocean floor. We drag sonar over it and hope. So when a Soviet team pulled that 11,000-year-old tooth from the Pacific in 1975, the scientific community had 2 choices. Option 1. The dating method was flawed. Manganese dioxide encrustation isn't the same as radiocarbon dating. It tells you how long the tooth has been sitting on the seabed, not how long the animal has been dead. Option 2. The tooth was younger than 3.5 million years, which would mean Megalodon survived far longer than we thought. Most scientists chose option 1. The dating was probably contamination. Probably an artifact of older fossils being moved by currents. Probably a coincidence, but probably is not the same as proven. And there's a reason that distinction matters here, because the place those teeth came from. It wasn't an ordinary part of the ocean. The Mariana Trench is the deepest place on Earth. At its deepest point, called Challenger Deep, the seabed sits 10,935 meters below the surface. If you took Mount Everest and dropped it into the trench, the summit would still be more than 2 kilometers underwater. Only a handful of humans have ever been to the bottom. The first were Jacques Piccard and Don Walsh in 1960. The next was filmmaker James Cameron alone in 2012. The pressure down there is over 1,000 times what you feel at the surface, roughly 15,750 pounds per square inch. It would crush a human body in a fraction of a second. The temperature hovers just above freezing. The darkness is absolute. No sunlight has ever reached that depth. And yet, the trench is alive. Scientists have catalogued more than 200 new species there in the last 20 years alone. Bacteria that feed on rock, crustaceans that grow to enormous sizes, snailfish that survive at depths once thought impossible for vertebrates. Every expedition to the trench finds something we've never seen before. Every single one. So the question stops being whether the Mariana Trench could hide a giant predator. The question becomes whether we'd ever know. If you're enjoying this so far, do me a favor and hit subscribe. Because what comes next is the part of the story that even most marine biologists won't say out loud on camera. By 1938, biologists were absolutely certain the coelacanth was extinct. The coelacanth was a deep water fish whose lineage stretched back 400 million years. Older than dinosaurs, older than trees. Every fossil ever found of it dated to before the asteroid impact that ended the Cretaceous. Then a fisherman named Hendrik Goosen pulled one out of the Indian Ocean, alive, off the coast of South Africa. The animal had survived 66 million years longer than science believed. Not by hiding in some remote pocket. It had been swimming in the same waters fishermen had worked for centuries. Nobody had thought to look deeper. The coelacanth wasn't an exception. It opened a category. In 2007, fishermen pulled up a colossal squid weighing nearly 500 kilograms. Until then, the species had been known almost entirely from beak fragments inside sperm whale stomachs. Nobody had photographed a complete adult. In 1976, a US Navy ship accidentally hauled up a 5-meter shark with a giant mouth. It was a species nobody had ever documented before. They named it the megamouth shark. We've seen fewer than 300 of them in the half-century since. The pattern is clear. Big animals, deep water, long timelines. Our certainty about what is and isn't out there is built on fishing nets and chance encounters. So, if a fish older than dinosaurs can survive 66 million years in waters fishermen visit every day, what does it mean when we say a shark went extinct 3.5 million years ago in waters we've barely visited at all? That brings us to the part of the story that's hardest to dismiss. Now we get to the actual science. Could Megalodon physically survive in the Mariana Trench? The answer, according to the people who study this animal for a living, is almost certainly no. Megalodon was not a deep-sea animal. The fossil evidence places it in coastal sunlit waters between 0 and around 200 meters deep. It hunted whales and dolphins, animals that breathe air and live near the surface. Its body was built for warm water cruising, not abyssal pressure. A 15-meter shark would need to consume roughly 1,000 kilograms of meat every single day just to stay alive. The Mariana Trench, for all its strangeness, is a food desert. The only available prey is small. Snailfish, amphipods, microbes. Nothing that could sustain an apex predator the size of a school bus. There's also the question of what we'd see if Megalodon were down there. Sperm whales dive to depths of 2,000 meters regularly. They are the natural prey of any deep-sea giant. If a population of megalodons existed, we would expect to see bite marks on whales, scars from failed attacks, and dead whales with tooth fragments embedded in them. We have found exactly none of this. So scientifically, the answer is settled. Megalodon is gone. But here's the part that won't quite let the question die. In 1997, hydrophones operated by the US Navy and NOAA picked up a sound from the deep Pacific that was louder than any animal vocalization ever recorded. They called it the bloop. For years, theories about giant unknown sea creatures circulated. NOAA eventually concluded the sound was an ice quake from Antarctica. But the Pacific is full of these unidentified noises, dozens of them, every year. Some of them have never been explained. And every time scientists send a submersible to the deepest places on Earth, they bring back something nobody predicted. A jellyfish that glows, a shrimp the size of a cat, or a new fish at a depth that should have been impossible for any vertebrate. The trench keeps surprising us. So the rational position is this: Megalodon almost certainly cannot be hiding down there. The biology says no. The food chain says no. The lack of evidence on whales says no. But almost certainly is the most honest a scientist can be when 80% of the ocean has never been seen. Here's what's strange about Megalodon. It was one of the most thoroughly studied predators in the history of paleontology. We know its size, its bite force, its hunting behavior, its breeding grounds. We know what it ate, how it grew, and what its babies looked like. There are roughly 3,000 published scientific papers on this animal. We have more data on Megalodon than on most species alive today. And yet, when you ask the most basic question, when did it go extinct? The answer is a range of 1 to 2 million years. When you ask why it went extinct, the answer is a list of competing theories. When you ask whether it could have survived in some isolated pocket, the answer is almost certainly not. That gap between what we know and what we can prove is where every great mystery in marine biology lives. The 11,000-year-old tooth from the Pacific is, by scientific consensus, a dating error. The mainstream view is that the manganese dating method gave a falsely young result, and the real age is millions of years older. The mainstream view is probably correct, but probably is the word that keeps getting people back into the submersibles. Because for now, here is what we can actually say with confidence. Megalodon went extinct millions of years ago. Probably. The deep ocean keeps almost everything it has ever held. Always. And the only honest answer to the question, could it still be down there, is the same answer scientists have been giving for the last 50 years. We just don't know. The real question isn't whether Megalodon is hiding in the Mariana Trench. It's how comfortable we are calling something extinct in an ocean we've barely begun to map. Every year, deep-sea expeditions return with species we didn't know existed. Every year, the line between extinct and undocumented gets blurrier. And every year, somewhere in the dark trenches that ring the Pacific, something is moving that no one has ever filmed. It's almost certainly not a 60-foot shark, but almost is the word that keeps the lights on the submersibles. If you want to go deeper, watch the next video on the screen. Because Megalodon isn't the only creature science has buried that the deep keeps refusing to let go of. Subscribe so you don't miss it.